Welcome to the Code with Jason meetup. We are not going to do Saturn CI today like we normally do. We're going to do something different, which I shall explain. So, as you may know, dear viewer, and as I think you guys know in this meeting right now, I make my living as a consultant. I help people with automated testing and object-oriented programming, among other things. And as a consultant, I get to see a lot of different code bases. Also, I've been programming for like over 25 years, if you can believe it. I started when I was just a kid. So I've been programming for a really long time, and I've had a lot of different jobs, and just I've seen a lot of different code bases. And I have yet to see like an actual good one, I'm sad to say. And I bet it's the same for you guys. Like, have you guys ever gotten a job somewhere and open up the code base and you're like, wow, this is like really good?
No.
Yeah, I didn't think so. Um, and something that I find in Rails apps specifically, I don't see a lot of other kinds of apps, but in Rails apps, I see what I think is a lack of good object-oriented programming. A lot of Rails apps have kind of the same shape to them. They suffer from similar symptoms. And I can point out the problems, and the problems aren't too hard to articulate. But the hard part is when people say, okay, Jason, I get it. You don't like service objects or whatever. You don't like these other things. What do we do instead? That's a little bit harder to answer. That's a lot harder to answer. Entire books have been written about the answer, and I'm writing a book that hopes to partially answer that question right now, which is my testing book. But what I wanted to do today was I wanted to write some object-oriented Ruby code with the hope of conveying some of the principles that I want to convey to help answer that question of like, how should we structure our code in Ruby on Rails apps if the way that we're doing it now is not great? So what we're going to do is we're going to take we're going to take some material from the book that I'm working on, and we're going to do a little bit of test-driven development, but the primary focus isn't necessarily on the tests, it's on the object-oriented code. So first thing I'm going to do is share my screen and share this part of my book that I'm talking about. Okay. So easiest way probably is to open up the PDF of my book so I can find the exact spot. Bear with me a second while I deal with my browser's quirks. Welcome, Hassan. Speaking of quirks, Zoom is kind of quirky. And so when people join, I don't know if people can hear me in the first few seconds. So I'll say it again. Welcome, Hassan. Maybe you heard me before and you just didn't say anything back. Okay,
Hey,
anyway, hey, the first chapter in my book is chapter two, but chapter one is just the intro. The first chapter in my book is tests as specifications, with the idea that being that tests are executable specifications, and we can begin writing our programs by deciding what we want the program to do. And this is kind of a sorry, welcome Francisco.
hello.
Where are you located?
I'm in Mexico right now.
Oh wow, where in Mexico?
Central Mexico, Jalisco, near Guadalajara.
Jalisco. I've heard of it.
Yeah, it's where tequila was born.
Oh wow.
Yep.
I drank a lot of tequila about 15 minutes before this video started.
Oh, perfect. I'll make you
Yeah.
extra productive.
Yeah, it helps me think.
Yeah, helps you clear and relax. Yeah.
Yeah, and we have, I think, what I think is a Jaliscan restaurant here in Michigan where I live. They have this dish that I really like. It's like octopus. You can get it a couple ways, but you can get it with this like garlic sauce. Does Jalisco have a lot of seafood?
Yeah, it definitely has a lot of coast. So you probably had like a grilled octopus.
Yeah. Yeah, it was
Yeah.
really good.
And that restaurant, there's a word called tapatio. That's usually
Hmm.
what they refer to people from Jalisco.
Oh,
So you
interesting.
so you might see that word in areas, you know?
Okay.
Yes, sir.
Um, well, I always enjoy learning about different parts of the world. Well, thanks for being here. And is this your first Code with Jason meetup, by the way?
I joined once like a while, maybe like a year ago or something.
Okay. Yeah,
Yeah.
actually, maybe I even remember that.
Yeah.
Um, anyway, continuing on with what we're looking at here. Francisco, today we were going to do some test driven development and object-oriented programming.
Hmm.
So when I start a new program, I like to think of at least some of the specifications for the program, and I like to think of it in terms of scenarios and expectations. So here's an example that I give in my book, and I'll make this a little bit bigger if I can. Um, let's say we have an authentication feature. One scenario might be when a user enters a valid email address and password combination into the email and password fields and then click sign in, our expectation is that the user's dashboard page is shown. Pretty straightforward. Another scenario may be when a user enters a valid email address into the email field, but an invalid password into the password field, and then click sign in. We have two expectations here. One is that an error message appears saying unable to sign in, and the other is that the user's dashboard page is not shown. One final scenario that I listed here, when a user leaves the username and password fields blank, we have three expectations here. One is that we see an error message saying email can't be left blank. Same thing for password. And then we expect again that the user's dashboard page is not shown. So I share this just to share my habit of thinking of the specifications for a program before I start writing the program.
I was
Here's,
looking
yeah,
at
go
sorry,
ahead.
I was looking at your like kind of the language that you're using, and it
Hmm.
reminded me, you've seen that given, when, then.
Exactly. I mean,
And I
not
saw everything started
exactly,
with
but very
when.
close.
Everything started with when, I noticed in your sentences. Yeah.
Yeah. Yeah. I personally don't really feel like, I don't always feel like the given part fits in so much. I feel like it's kind of adds an unnecessary element to it. I get enough out of just when this, then we expect that.
Okay.
Um, uh,
I felt like you did use
mhm.
that exact breakdown if you go back up to your
Yeah.
uh, test because you the in Gherkin the given part would be everything up to where you have the then, and the then would be uh, the actually so the where you have it as when Gherkin would have it as given, where you have it as then Gherkin would have it as when, right? It's the action that the user does. And then the then is your expectation. So I think you've actually done this exactly like
There's
uh,
three components
Gherkin and
there for
Cucumber.
sure.
Yeah. And
Hmm.
they're the exact they they're they're exactly in line with the three components in Gherkin.
Okay. I reluctantly buy that. I only say reluctantly because I positively loathe cucumber, but that's nothing to do with this gherkin format or anything like that. Um so
Yeah.
that's not why. So I guess I'm not uncomfortable with the idea that this matches that format. But just to be clear, that's not that's not exactly the angle that I'm trying to come from. Or maybe it is. I don't know. In any case, my preference is to format it in scenarios and expectations. And if it happens to match up with the Gherkin formulation, then that's fine, I guess. Okay. Now, I'm not gonna have us go through an example that does authentication or something because that would involve an entire web application and we'd have to have something that a tool to manipulate the browser. We'd have to have data in a database and stuff like that. It would just be too much baggage. So instead, I'm going to have us do a command line Ruby program. It'll be something to parse a mathematical expression. So here's an example. Like if we have an expression of 2x plus 5, we could represent that as a tree. And by the way, I didn't figure this out. This is just I like read this a long time ago and then ChatGPT reminded me recently. But we could represent 2x plus 5 as a tree. So at the root we have plus, and then the plus operator has two operands. One is 5. So on the right-hand child here we have 5. And then the other child of plus is actually a second expression, this 2 times x expression. So the left child of plus is this expression that has times at the root. And then, of course, this times expression has 2 as its left child and x as its right child. So every mathematical expression can be expressed as a tree like this. And just to kind of drive that home a little more, I did a second example here. This one's a bit more complicated. And it might be easiest to go from the bottom up. So if we have like 5x plus 1, for example, I'll start with the 5x part. It's 5 times x. So we have times at the root of this one, and then 5 as the left child, x as the right child. And again, it's 5x plus 1. So at the root of that, we have plus. The left child is the sub expression, and then the right child is the number 1. Then if we start from the bottom over here, we have x squared at the very bottom. This exponent character, exponent operator is the root here. Left child's x, right child's 2. That's part of a larger expression, 3x squared. So we have times, 3 times x squared is the expression here. So we have times at the root, 3 is the left child, and the sub-expression is the right child. And then this whole thing, which actually we should be looking at this one, this whole thing has 2 parts. The left child is 3x squared, and the right child is 5x plus 1. And at the root of that, we just have plus. So that's more of a complicated one, just to show what it might look like to parse something more complicated, but we're not going to get to anything nearly this complicated in the coding we do today. We're going to deal more with stuff that looks like this.
Yeah,
Okay.
when I saw that example, I
Mhm.
noticed like the parentheses, like how are you gonna do that? But PEMDAS,
Yeah, the thing is, when I
order.
saw this expression, I just kind of randomly came up with an expression. I'm like, wait a second, this has not 2 terms to it, but 3. So am I going to have like 2 children for some expressions, but 3 for some others? But then
Yeah.
naturally, I plugged it into ChatGPT and it suggested using parentheses to just turn the 3-term expression into a 2-term expression. I thought that made sense. Okay. So what I want to do now that I have like a general approach, I want to, or I don't know if I'd even call this an approach, but it's kind of, we framed the problem a little bit at least. Now I want to come up with some specifications because I want to get very specific about what I want to do. I want to have it written and I want to have as little ambiguity as possible. Um, and I want to kind of code it from the bottom up. You know, when we looked at this more complicated expression, we went from the bottom up. The reason I went from the bottom up is if we start at the plus, it's just like too much stuff. It's just too complicated. It's too much to think about at once. I want to take a similar approach with the whole program. This is like kind of a hard thing, and I don't want to have to think about too much stuff at once. So I'm going to start from the bottom, build those little pieces, and then take those little pieces at the bottom and then build on top of that until I have my full program. So let's not deal with big expressions like this. Let's just deal with individual terms. So, for example, 2x, that's a term. And then this little tree here with times at the root and 2 and x as the children. Let's deal with expressions like that. So, I don't know how familiar you guys are with this terminology, but this whole thing's an expression, and 2x is a term. 2x and 5 are both terms, and every term is also an expression. But I don't want to be dealing with these multi-term expressions. I just want to be dealing with single-term expressions. Again, because I want to go from the bottom up to make life a little easier for myself. So here are some specifications that we could list for single-term expressions. Here's the first scenario, when the term involves multiplication with an explicit operator. So like 2 times x rather than 2x. We have 3 expectations. One is that the root term is times. Left child is 2. Oh, I have typos. This is a draft. I mean, it's a work in progress. But anyway, it's supposed to say the right child is x. And then here, the scenario is where there's an implicit times operator, just 2x instead of explicitly 2 times x. We just expect the exact same things. And then I added a different case here when we have division, like x divided by 3. We expect that the root of the term is the division operator. Left child is x, right child is 3.
So,
Okay,
Jason, I have a question for you on these tests. Do you think it
yeah,
might be useful to have a test that just if you gave it a single number?
absolutely. In addition to these 3 specifications, if we were to start thinking, I bet we could come up with, I don't know how many, 5,
I guess,
10.
yeah, I meant as a starting point.
Oh, as a starting point.
Yeah, not in terms of being exhaustive, but as a starting point. Like what's the simplest thing you could accomplish kind of thinking?
Yeah. Okay. Let's think about that. I'm going to actually go to where I can edit this stuff. Um, explicit operator. Oh, but this actually might be too small for people to see. Let me at least just fix my typo before I forget. Right child, right child, right child. Okay. And so James, just so I can write it down, what was the scenario you were suggesting? It's when we just give it one, like a constant number.
Yeah, or even just it could be a single term, however you want to say it. It could be a number or it could just be X.
Okay. Yeah, I'm just gonna say when the term is a constant, example, the number 5,
Yep.
and then the expectation is the root of the term is 5.
Or
Uh,
no.
the term has no children. Yeah. And bear with me. I'm just gonna regenerate my PDF here. Okay. So here, when the term is a constant, the root we get is 5, and the term has no child nodes. All right, so what I'm going to do now is I'm going to get into the coding of it and translate each one of these scenarios and expectations into a test. I don't even have a project yet. I'm going to call it expression parser. And I have a process for writing tests, which I documented in my book here. My objective here was to break the process of writing a test down into the smallest possible parts with the idea of making the cognitive burden at each step as low as it can possibly be. So what do we have to do? What's the first thing we have to do when we write a test? Well, we have to put it somewhere. And so that's the first decision I make is what to call the file. And that's obviously like a very small decision, but I think it's worth thinking of consciously as a step. A lot of developers get kind of writer's block when they go to write a test. Part of the reason is they try to think about too many things at once. So again, my goal is to break it down into very, very small steps. So you just think about one thing at a time so that each individual step is easier. This is an expression parser. I'm going to call this test the dumbest thing I can, which is expression parser spec, because it does have to be suffixed with spec. I'm going to call it expression parser spec.rb. I am certain that I'm not going to want to keep that name, but I don't want to waste brain power on this file name right now because it will be, I guarantee that it will be substantially cheaper in terms of brain power to come up with a good name later rather than to try to come up with a good name now when I don't even know exactly what's going to be in the test yet. So that's the first step, file name. Second step is just to put the boilerplate of the test into the test. So this rspec.describe, the decision we have to make here is what do we put in the describe block? Again, I'm just going to put the dumbest thing, expression parser. I'm sure that that's not what I'm ultimately going to want, but I'm putting that just to have something. And again, it'll be cheaper to come back later and change it than to try to come up with something good right now. And what I actually do at this stage is I like to run my test, even though there's nothing there, just to show that I don't have any syntax errors. And if I do, I can correct them at this stage. But I'm getting this feedback loop started. My next step is I write my specification in prose. So not code, just human language. So let's take this one that James suggested. We say when the term is a constant, example 5, our expectation is the root of the term is 5. I'm going to edit this just lightly for grammar. When the term is a constant, e.g. 5, the root of the term is 5. Even though it might seem dumb, I run the test again, just out of habit of every time I edit the test, I run the test so that if there are any syntax errors, I can deal with them then. I don't want to have to, after I write some actual like real test code, I don't want to have to be dealing with syntax errors at that point. I want to get those out of the way now so that when I write the test code, I can focus wholly on the test code. Okay, so the next step is that I take this specification and convert it into a little bit of organizational test code. So again, the scenario here is when the term is a constant and the expectation is that the root of the term is 5. So I'm going to translate the scenario into a context block. The term is a constant. And then I'll translate the expectation into an it block. It has a root of 5. Okay, and then I will run that. Then the next thing that I do, oh, sorry, let me get rid of this. Don't need that anymore. It served its purpose. The next thing I do is that even though I haven't written any code yet, I call this, what do I call it? I call it outside in design. I don't claim that I invented that, but that's what I call it. I start with the code that I wish I had, and then I fill it in from the outside in. So here's what that looks like. I'm going to start with expression equals expression dot parse 5. So I'm imagining an object called expression, and I'm imagining that it has a method called parse into which I can pass a string. And then I'm going to say expect expression dot root dot value to equal 5. And note that I'm parsing a string, but I'm expecting an integer. And expression dot root dot value, where does that come from? I'm just making it up. So I'm expecting an error. We get an error. It says uninitialized constant expression. Okay. Not surprising. We can create a class called expression. Okay, it still says that. That's because I forgot to include it.
Oh, it's a regular Ruby project.
Yeah, no Rails.
Rails.
I want to strip it down to just, I want to show as much as possible just the principles and not muddy the waters with tools and such. Okay, so we took care of the uninitialized constant expression error. Now we're getting undefined method parse. So I'm going to write enough code to make that error go away. Okay, now it says wrong number of arguments. I'm not sure what to call this. Maybe I'll call it value. Okay, undefined method root for nil class. So it's saying that because the value returned by expression.parse is nil. So let's instead just return a new expression. Now it's saying undefined method root for expression. So we'll fix that. Undefined method value for nil class. All right, so the return value of root is nil. So when we do expression.root.value, it's saying, well, we can't do dot value on nil. So we need to return something.
What if you just made it value, def value, not root?
I was
Okay.
wondering that too.
Just to make it easier and less and get that feedback, a little quicker maybe.
Okay.
And you could even hardcode value to 5.
Yeah. Okay, so we have a passing test here. Just by way of explanation, my thought is 5 is not the value of the expression. It's the value of the root node of the expression. But we can get there bit by bit.
Okay.
Okay, so I think maybe that fulfills that first expectation in a way, at least. Expectation, okay, when the term is a constant, the root of the term is 5. Okay. And then the other expectation is that the term has no children. This actually, I think, is a little bit imprecise. I think if I should have had 2 expectations, one that it has no left child and one that it has no right child.
Okay.
We can do this. It has no left child and it has no right child. So we can say expect expression dot left child to be nil.
There's a typo right there.
Oh, where is it?
Line 12, expect dot left child. It should be.
Oh, yeah. No. Okay. Okay, undefined method left child, not surprising. Okay, now that passes. You can do the same thing with right child. Similar error. Whoops. That passes, and if we run all the tests, they all pass. I'm going to commit what we have.
Green bar.
Okay. Initial commit. Okay. Oh, and I guess first object-oriented comment here. Notice how I didn't create an object called expression parser. If you have a class that ends in ER, it's a sign that it might be an unimaginative class. Instead, I have this thing called an expression, and we can bring a new one into existence by calling this parse class method. But the parse is not the thing to focus on. The thing to focus on is the value and the left child and the right child. So it's not an expression parser, it's an expression with, I'll say, root and left child and right child. This parse just happens to be a convenience thing. So again, don't focus on the parse.
It's a factory method, right?
Yeah.
It's your initializer. It's your construct. No, yeah, no, it's your initializer. It's a factory method. Yeah, I think.
Yeah, I'd call it a factory method. And just for cleanliness's sake, see we have this duplication here. This appears 3 times. I'm gonna factor this out.
A little let block.
Yeah.
What does bang mean on let?
Uh-oh.
Oh,
Here comes this
man.
discussion.
Oh, I see bang. I ask questions.
So I don't want to get sidetracked on this, partly because I have to end promptly at the end of the hour. But let difference.
Is it like the evaluation or something?
Yeah, if
Yes.
you search for the difference between let and
Oh,
let,
memoized. Okay.
yeah, I'm
Memo.
like not a fan of this design choice in the RSpec library. I wish that let bang was the only version of let that existed. But long story short, if you use let bang, it evaluates this expression. Don't get confused between expression and expression, but it evaluates this Ruby expression immediately.
Okay.
Whereas if you use the non-bang version, it evaluates it lazily, which, in my opinion, only
It's
serves to
weird.
cause confusion.
Okay.
So I always use the let bang version.
Gotcha. Thank
Yeah.
you.
Okay. So now let's move on to this next scenario when the term involves multiplication with an explicit operator. Oh, so again, let's do it the way that I showed you. So we can say, I'm going to grab this. And by the way, this is a process that I kind of have down myself for my own work, but my process for teaching my process is still a work in progress. So I'm going to make some adjustments on the fly. All right, so last time I kind of adjusted this into a single sentence. This time I'm going to keep it as scenario and expectation here because that'll allow us to neatly do some mapping here. We can say context, blah, blah, blah. And then it has a root of not exclamation point. What do you call this thing? Time
Asterisk.
sign, multiplication operator,
Asterisk.
asterisk. Okay. So we can do 2 times x. And this has served its purpose. It can go. I'll run this. Okay, everything's fine. So we can say expect the root to be asterisk. And you know, I don't feel like value is an appropriate name, but we can just rename it to root.
Okay.
Okay. Where am I still saying value? Expression dot value. Parser spec line 24. Oh, I didn't save it. How embarrassing. Okay, expected asterisk and got 5. Now this forces us to confront our cheating that we did here and do something that's actually real. So one way of doing this is we could split it on asterisk. Let's see. How do we do this? We take the value, maybe we do new value, and then we have an initializer. And then we say value equals value dot split on asterisk. And then for root, I'm just going to put an asterisk, but obviously that's not going to work.
So you'd be splitting on left and right childs, right? The first element left and
Right.
second element right.
Yeah, instead of at value, you probably want this to be the left child and the right child. Or maybe you, for left child and right child, you create a new expression passing in the first argument of, or the first array element that split returns to right child.
Oh, that's right. Child should be expressions. Yeah, that makes sense.
Yeah. So I would say, and to me, the word value, you use the word term in your document. Maybe that should be term. I don't know.
Okay.
Good observation.
I'm listening and
yeah, I think the thing is that I was trying to get to is that you use term a lot in your specification. I don't see it here in the code. What is a term and how is it different than an expression?
yeah, that's actually something we're going to need to talk about because I made some, I was sloppy in certain ways in that area. So we're going to have to talk about that. But even before that, I've been setting a bad example. I've been coding speculatively. And by that, I mean, I've been writing more code than what's necessary to satisfy the expectations of right now.
I
All
feel
this,
like that's why you came up with the word root in the beginning. And I was thinking of a way to say that as well. But yes, that
okay.
fits it.
Yeah, like all this split business, this is premature. we can do something simpler that only meets these requirements. We can say if value.length equals 1, then value equals value, else value equals asterisk. Oh, and that didn't work. Oh yeah, because we got to do this.
Yeah.
And why am I doing this? This is not the right thing. Root. Yeah. Okay, we expected 5, got 5 in quotes, value.2i. Okay. So this is stupid, shitty code, but that's okay.
That works.
Yeah, because it meets the current requirements and no more.
Yep.
And the reason why I don't want to code speculatively and add more code than what's necessary is because all code has a cost. And if we add code beyond what's necessary, we'll have to pay the cost of lugging that code around, but we don't have good evidence that that code has value. So we don't want to have a cost without value. If we have a test for a piece of behavior, then we're going on the presumption that having a test for a piece of behavior means that that behavior has value. So again, we don't want to have cost without value. So we're only writing code to meet the test because that's the only code that we can be sure has value. Okay, so all the tests pass here. So I'm going to commit this. First, I'm going to review what I wrote. No surprises there. So I'm going to say, what did I do? I added a case for multiplication. Multiplication. Okay. Okay. Now I'm just going to observe that I feel a little weird about this. It's a method that just has this instance variable, but I'm not going to worry about that for the moment because I suspect that this is going to change. But let's move to the next expectation. The left child is 2. Okay. As a left child of 2, we'll expect it to be 2. Left child.
But do you want to use a primitive, right? Okay, we're gonna do primitives right now, but later you'll make that an expression?
I think so. That's a good question. I think so.
Okay, got it. That's for the next test.
Yeah, and by the way, so the sloppiness that I referred to earlier, I've been using the term sometimes and expression sometimes, but every piece of every expression is itself an expression. So I think it makes sense to think of an expression as a tree of expressions. Even each one of these leaves here, 3x2, blah, 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 each one of those is an expression. So all these are expressions. It's just some expressions have children and other expressions don't.
And there's no case left child and right child, or they either have to have values or no values at all, right? Because if it's the leaf, there's no children, correct? Yeah.
Yeah, would an expression ever have just one child?
No, no child.
If you had a unary operator,
Oh, damn it. Okay.
like like -1,
Oh,
or maybe
yeah,
that's,
-1.
Damn. Okay. I
but
didn't think about
because,
that.
yeah, the negative can, like, if -1, you might say, well, that's just a value, but a negative, well, how would you handle -x then?
You could just call it 0 minus x, I suppose. Oh, but what about square root? Square root of x.
There you go. That's probably a more clean.
Damn. Okay. Good stuff.
Okay. So expected 2 and got nil. Obviously we can just cheat and put 2, and that takes care of this particular test. But then if we run all of them,
No,
that
let's
doesn't
do it
work.
right. Let's do it.
Yeah. So I think we can say this. I'm not going to worry about whether this code is good. I'm just going to try to make it work. Parts equals value dot split asterisk left child equals parts dot first. I was going to put right child, but that would be coding speculatively. So we'll just have this left child. Okay. Oh, and we have to have left child here. Okay. Expected 2, but got 2 as a string. Okay. Now everything works. I'm going to commit this. We'll review it first.
Green bar.
Add left child. Okay, so I'm noticing a pattern that I think needs attention. These methods should probably just be accessors. So we can do,
Just some attribute readers.
yeah. It really is just a data structure anyway. Okay, so that's going to make some stuff fail. Or not.
No.
Yeah, I wouldn't
Oh,
have
yeah,
expected
yeah.
it to.
Okay, that makes sense.
Yeah.
What a wonderful refactoring. Oops,
Works
I
as
forgot to
expected.
review. Okay, now we can add right child. X.
But you gotta change line 32 to make it right child expectation.
Oh, whoops. Thank you. Okay, expected X got nil. That's not surprising. So we will say right child equals last.
Without the 2i.
Right.
Yeah, because that would be speculative. Oh, not
No,
because
not
it would be
speculative.
speculative, because
Real.
it's just wrong otherwise.
Yeah.
Right.
Yeah, okay. We have less than 60 seconds left. Let's see how far we can get. Add case for right child. Okay, I think the next case is where we don't have an explicit times operator. Oh yeah, here we are. Yes. So this will be interesting. And I should clean up my language here. Expression, expression, expression. Okay, when the expression involves multiplication, I'll say without an explicit operator. So just 2x like that.
Oh,
We're gonna,
damn. Okay. It's getting juicier.
yeah. So
Gonna
we'll
have to actually do
still,
some thinking.
we'll still expect a root of times. And what do you know? It actually works right out of the box. Just by coincidence, it works.
Right.
We won't be so lucky when we get to this, I think.
Yeah, yep. Once you get to
Wow. Okay.
Oh, because we had the 2i.
Yeah, what about this one? Okay.
No.
There, instead of x, we get 2x. Yeah, so how do we deal with this? Well, we can do
If
a
it's good.
we can do a split like not on, we can just do a split like that.
That'll break
And
up.
then maybe all these would pass. And that gives me a clue. We can say, well, a multiplication operator can be one of two characters. It can be an asterisk or it can be an empty string.
Yeah, but what if you had a 2-digit number?
Yeah. So how do we tell the difference between a term and a number? Sorry, how do we tell the difference between an expression that's a constant and an expression that is
Variable.
multiplication of a variable? And I think the answer is the presence of a variable.
You're gonna search for asterisk, search for X. Is X the only variable name you can use? I guess for now.
For now. Yeah, so maybe we can actually flip this and say if value dot includes X, then do that stuff. Otherwise, do this. Does this stuff still work? Nope. I think it's supposed to be include also.
Yeah, singular.
Yeah. So that works, but oh,
Yeah, I would expect all that to work, but it's super brittle.
oh yeah, because it doesn't care about the root. Or I mean, it only cares about the beginning and end. So it doesn't matter whether it's 2 or 3 elements in the array.
Right.
Fascinating. Okay.
Total luck.
I'm like 3 minutes over. So I got to wrap up ASAP, but let me commit this.
Getting juicy.
Yeah. Add case for multiplication without explicit operator. Okay. Now I want to end with a loose end hanging. So we'll say when the expression involves division and do x divided by 3, it has a root of division operator. And of course, this will not work. We're expecting division and we get multiplication. So I'm going to leave it there. Obviously, we only got a really small ways of the way there with the OOP part. And this class looks like garbage, but that's fine. Side comment, it's less significant what a piece of code looks like, and it's more significant how that piece of code is changing over time. Is it getting worse or is it getting better? And I like to think that this piece of code is getting better. That is yet to be proven. But if you have a production code base and it's bad and getting worse, that's a much different story from if it's bad and it's getting better. What you see at any particular moment in time is just a snapshot that doesn't contain a lot of meaning, actually. So I'm comfortable with the fact that this doesn't look very good because I'm more concerned not with what it is, but with what it's becoming. And I think you can thank old Heraclitus for that wise way of looking at the world. Okay, so we only got a little ways with the application code. We have a few test cases in here, and I'm pretty happy with those. And when we pick back up, which I intend to do in our next session, unless we have a mentee in the next session, but when we have our next solo session, I intend to pick back up where we left off. And if any of you guys want to, just for fun, you could make your own expression parser and try to write your own tests and see how far you get. And I'll just say, if any of you guys want to do that, you want to come back and we can share your screen and you can code instead of me, I would be very happy to do that. That offer extends to the people here in this meeting and you, dear viewer on YouTube, if you like. Okay. Thanks everyone for joining me, and I will see you next time.
Thanks, Jason.
You have a good one, Jason.
You too.
Goodbye.